Welcome back to lesson 67, where we're going to continue today talking about our inverse trig functions. Yesterday in our lesson, we talked about how if we had to give all of our answers, we had to add that extra piece of plus 360n if we were giving the answer in degrees, or plus 2 pi n if we were given the answer in radians. We finished up yesterday's lesson by looking at our capital letter questions. Remember, the capital letter questions only have one answer. There was a certain restriction that we had to give. Today's questions are going to be lowercase letters. Now, we're going to notice, and make sure you note this in your notebook here or on your circle paper, a lowercase letter is going to have two answers. There's two spots on the Cartesian plane where there's a certain requirement that has met. So all answers was our plus 360n. Capital letter question was one answer, but a lowercase letter is going to be two answers for our question. So let's work through a couple of those examples together. My job is to solve, given that my theta, my answer, is in between 0 degrees and 360 degrees. So that just means my answer is somewhere on the circle that we have on our Cartesian plane. Well, the question that we have says 2 cosine theta minus 1 is equal to 0. Our job is to determine the theta that is going to make that equation true. Now, just like any other basic algebra equation, we want to get the variable part by itself first. Well, what's the variable part that I have in the question? Cosine theta. The theta has to stay attached to the cosine as we're continuing to work on our question. So the first thing I want to do on this question to get the cosine part by itself is add 1. So I have 2 cosine theta is equal to 1. Now, to continue getting cosine by itself, I need to get rid of the 2 that's right in front of it. So it says cosine theta is equal to 1/2. At this point, now that the cosine is completely by itself, is where we can pick out the answers from the Cartesian plane. Notice that I see cosine is a positive ratio. Where on the Cartesian plane is cosine positive? It's two different locations. Remember, in quadrant number 1, everything is positive. So I know I'm going to get an answer out of quadrant number 1. Where else is cosine positive on the Cartesian plane? Quadrant number 4. So again, this is a lowercase letter question. Lowercase letter questions always have two total answers. So let's go ahead and take a look at quadrant 1. Remember, cosine is the x. Which angle in quadrant number 1 has a cosine of 1/2? That would be our 60-degree angle. Which angle in quadrant number 4 has a cosine of 1/2? That would be our 300-degree angle. So I have two answers, 60 degrees and 300 degrees. I don't need to, like we did yesterday, say negative 60 for that fourth quadrant, because I am allowed to spin all the way around the Cartesian plane. So yesterday's capital letter questions would have only been one answer, but now that I have a lowercase letter question, I can give two answers in our question. Let's do one more like this, where we can give a total of two possible answers. Because of the limitation on the top, my theta has to stay within one rotation of our circle, and there's two different quadrants where things are positive, and there's two different quadrants where things are negative. We have 3 tangent theta plus 3 is equal to 0. Just like we saw in our cosine question, we want to get the trig part all by itself. So what do I need to do first? I'm going to have to get rid of the plus 3, so I'm going to subtract 3. So 0 minus 3 gave me negative 3. So 3 tangent theta equals negative 3. To finish getting the trig part by itself, I'm going to get rid of the 3 in the front, so I'm going to divide by 3. Negative 3 divided by 3 is negative 1. So my tangent of theta is equal to negative 1. Again, this is a lowercase letter question. Lowercase letter questions always have two total answers. Now, you should already have marked on your circle where tangent was positive. We know tangent is positive in quadrant number 1 because everything is positive there, and tangent is also positive in the third quadrant. Well, the ratio that I have here says negative 1. Well, if tangent's positive in the first and the third quadrant, then that means it's negative in the second and the fourth. So I'm going to give two answers, one from the second quadrant and one from the fourth quadrant for our final solution. Now, using my definition of tangent, I know that tangent is y over x. So if I divide a fraction out and I got the answer of 1, that meant what was in the numerator would be the same thing as what I would have in the denominator. So if I look at quadrant number 2, where do I see the same x and y? It is located at 135 degrees. In quadrant number 4, where do I see the same x and y in their ordered pair? It is at 315 degrees. So I have two total answers on this question, 135 as well as 315 degrees. So lowercase letter questions, we're always going to give two total answers for the two locations on the Cartesian plane that meet the requirement for our certain trig ratio that is given to us. Now, we have two more examples to work through along this idea here, but notice on this question here, it says use the given restrictions, and that's the limitations I see off to the side there, and it says my theta, or my angle, has to stay between 0 degrees and 90 degrees. Well, which quadrant is between 0 degrees and 90 degrees? It's the first quadrant. So that means on this question, even though it's a little letter question, a lowercase letter, which normally has two answers because I can use the entire Cartesian plane, this question only wants me to stay in quadrant 1, which means I can only give one answer on this question. Just like the previous problem, we want to get the sine by itself. So I'm going to divide by 8. So it says sine theta is equal to 5 over 8. Well, our definition for sine is involving the y. If I look at quadrant number 1 and I'm looking for a y of 5 over 8, it doesn't exist. So how am I going to come up with the answer for theta based on the fact that I have 5 over 8? That's where I'm going to have to use my calculator. Remember, we looked at in our lesson yesterday at the beginning, the opposite of sine is sine inverse. So in order to come up with our theta here on this question, I'm going to have to type into my calculator the sine inverse of 5 over 8. So if I do sine inverse 5 over 8, my calculator is going to tell me here an angle. If you can see that, you probably can't see it well on your screen. The answer it gives me is 38.68. Well, is 38.68 in quadrant number 1? It is, because my angle, my theta, was supposed to fall in between 0 and 90 degrees. Now, these questions, the same thing in our textbook, is always going to say give your answer to the nearest tenth, which is 1 decimal place. So I'm going to say that my angle is 38.7 once I round that in the question. So if the restriction would have been all of the Cartesian plane, that my answer can fall between 0 and 360, then I give two answers. This restriction between 0 and 90 only limited me to quadrant number 1, so I was only able to give one answer on this question. Now, let's take a look at this. It's actually the exact same problem. 8 sine theta is equal to 5, but it's a new restriction. It says that my theta, my answer, can only fall between 90 degrees and 180 degrees. Well, which quadrant falls between 90 and 180 degrees is quadrant number 2. So my answer has to be in the second quadrant, and there's only one second quadrant, so there's only one answer that I can give here. Start the equation the exact same way. So divide the 8 over, so I have sine theta is equal to 5 over 8. Now, if on my calculator, that was the question that we just did, and that gave me 38.7. Well, 38.7 is in the first quadrant, but I need my answer to be in the second quadrant. So how do I get 38.7 degrees into the second quadrant? I need to go back and use my idea of the reference angle. The reference angle was the distance to the closest x-axis. Well, if I'm in the second quadrant, the closest x-axis is 180 degrees. To get into the second quadrant, I need to back up. So to find my theta, I'm going to start at 180 and then subtract so I can back up, and I'm subtracting the answer that we just got from the first quadrant on our calculator of 38.7. If I subtract that, I get 141.3, and there is the second quadrant answer that we would have in our question. So please make sure that you read the restrictions carefully. This would affect on your homework something like questions. Let me take a look here. Question G and H look like they have a certain restriction on them, like I just walked through on these questions. So make sure that you only give the answer that falls in that quadrant. If it says your answer can fall between 0 and 360, then you would go ahead and give two of the answers like we saw in the first two examples today. Let's finish up with one last question here. This one actually starts in like a word problem format. Now, don't let that scare you because it's a word problem. We're going to draw a picture out and we're going to see how we can set up our question. So it says a 20-foot ladder leans against the side of a barn. The top of the ladder is 16.5 feet above the ground. Find the angle the ladder makes with the ground to the nearest degree. So if I had a ladder, the ladder would be leaning against the building. So that would be like the hypotenuse that I would have in the triangle. And it says the top of the ladder, so over here, is 16.5 feet above the ground. So that's going to give me the vertical distance that I have in the picture. So this is what that picture represents. The ladder is what I have going diagonal, and that had a length of 20 feet. The 16.5 represents the height that it was away from the ground. Our job was to find the angle that it makes with the ground. Well, where is the ground? It's going to be at the bottom, because that's usually where the ground is located. So I put my theta in that bottom left-hand corner. Now, how do I know how to correctly solve that? Just like we saw before, which trig ratio involves these pieces? From the theta, the 16.5 is the opposite side. The 20 is the hypotenuse. Which one of our ratios involves opposite hypotenuse? It is our sine ratio. So I said sine of our theta, our angle. The angle always came behind the ratio. So the sine of our theta is the opposite 16.5 over the hypotenuse of 20. I don't have something in my Cartesian plane that has that ratio, so we're going to have to use our calculator. If I'm getting rid of the sine, then I'm going to use my sine inverse. So I typed on my calculator the sine inverse of 16.5 over 20, and my calculator gave me the answer of 56 degrees once I round that to the nearest degree. All right, so we've noticed in our lesson, all answers means plus 360n or plus 2 pi n, because you can keep spinning around the Cartesian plane. A capital letter question limits you to one quadrant, depending on if it's sine, cosine, or tangent. And then a lowercase letter, if it says between 0 and 360 degrees, has 2 total answers in our question. So make sure that you read your homework questions carefully so you know which one you're trying to answer in your textbook.